So let's continue with composite functions. Now we have f of x equals 1 over square root of x, g of x equals x to the second minus 4x. And we are finding f of g of x, g of f of x, f of x, and g of x, and their domains. And once again, let's not mistake f of g of x with f times or f of x times g of x. So let's keep a record of what is the domain of f of x and g of x separately. Looking at f of x, I have f of x equals 1 over square root of x. So for f of x standing alone, the domain, we know that x has to be 0 or any positive number to have square root of x, but not 0 in this case, because when x is 0, square root of 0 is 0. But since it is in the denominator, I cannot have that. So the domain for domain of f of x is simply from 0 not included. So I have a parenthesis here. This is not a bracket, all the way to positive infinity. G of x is a polynomial, x squared minus 4x. So g of x equals x squared minus 4x. So the domain is all real numbers from negative infinity to positive infinity. There is no excluded value for g of x standing alone. So following the instruction, let's go to the next page and find f of g of x. So I have f of g of x. The inner function is g. I'm going to pick g of x and put it inside of f of x. So I'm going to have 1 over square root of x to the second minus 4x. And so remember that now I have to be mindful of the domain of f of g of x and the domain of the inner function, in this case, g of x. So I know that here, x squared minus 4x has to be greater than or equal to 0 for the square root this. So square root of x squared minus 4x is only meaningful if x squared minus 4x is greater than or equal to 0. But because this is in the denominator and I cannot have a 0 in the denominator, I have to, I cannot have that equal to 0. So what does that mean to us? That means that I have to find out my critical numbers. If I set x squared minus 4x equals 0, I can go ahead and to solve this, factor an x out. So I have x minus 4 equals 0. Using zero product property, I have x equals 0 and x equals positive 4. So those two are my critical numbers. Here's a number line. So if 0 is here and 4 is here, I'm going to go ahead and test numbers. Okay. To the left of 0, okay, to the left of 0, let's say negative 1. If I plug in negative 1, okay, in here, I have negative 1 squared is positive 1. And then I have minus 4 times negative 1 is positive 4. 4 plus 1 is going to give me 5, and square root of 5 is greater than 0. So I'm going to put a t for true here. So once again, remember that we said that x squared minus 4x under the square root must be greater than or equal to 0. So for any number to the left of 0, that gives me a true statement. Between 0 and 4, let's say 1. If I plug in 1 in here, I get 1 squared is 1 minus 4 times 1 gives me -3, and -3 is not greater than 0, so I don't have any solutions in here. How about to the right of 4? Let's say 5. 5 squared is 25, minus 4 times 5, that is 20. So I have total of 5, positive 5. So this is, I get solutions in this interval. So now I want to write down the domain of f of g of x. So domain of f of g of x. Remember that g of x was, let me write it here. Remember that g of x, the inner function was x squared minus 4x. There was no restriction. But the only times that, so now I'm going to only consider the final product of f of g of x. So from -infinity all the way to 0, 0 is not included. Why is that? Because once again, remember that if I plug in 0 in here, 0 squared is 0, minus 4 times 0 is 0, square root of 0 is 0, but all that is in the denominator, so I cannot have a 0 in the denominator, so 0 is not included. Together with, or union, or together with, okay, from 4 all the way to positive infinity. And once again, the 4 itself is not included. Once again, if I plug in the 4 in here, 4 squared minus 4x is 0. Square root of 0 is 0. That's true. But that because all this happened to be in the denominator, I cannot have a 0 in the denominator. So the domain of f of g of x is -infinity to 0, union, or together with, from 4 to positive infinity. Now let's do g of f of x. G of f of x. In this case, f is my inner function or inside function. So I'm going to put f and put it inside of g. So remember that g of x was x squared minus 4x, and f of x was 1 over square root of f. So picking up f and put it inside of g, I will have 1 over square root of x squared minus 4 times 1 over square root of x. So g of f of x equals 1 squared is 1, square root of x is just x minus 4 times over root x. Okay, remember that the inner function f of x in the beginning, we said f of x is 1 over square root of x. So x has to be, okay, x has to be greater than 0 for this to be meaningful. And 0 is not included because I cannot have 0 in the denominator. All right, well, notice that for the domain of g of f of x, x has to be greater than 0, and x has to be greater than 0 in here. So there's nothing new to introduce. So the domain of g of f of x is from 0 to infinity. Okay, let's go to the next page and do f of x. So what is f? Let me change color. What is f of x? This means that I pick f of x and put it inside of itself. So remember that f of x from page 1 was 1 over square root of x. So now here I will have 1 over square root of, instead of x, I'm going to put the f of x, 1 over root x. Okay. So here, since I want to show my work really, so it's easier, you can see it easier, I'm going to remember that square root of x is the same as x to the power of 1/2. So let me rewrite that. Let me go to black color. So f of x equals 1 over. Okay. So here I have 1 over x to the 1/2. And then because of this square root, this is to the power of 1/2. So now let me give myself a little bit more room. Change color. So this is the same as saying 1 over the denominator. Remember, since this is power, I'm going to rewrite this as 1 to the power of 1/2 over x to the 1/2 to the power of 1/2. And so that changing color equals, here's the 1 on the very top, okay, over x, 1 to the any power is just 1. So this is just a 1 over x to the 1/2. I have power of power. 1/2 times 1/2 is 1/4. So I have x to the power of 1/4. So this is the same as saying 1 over 1 times x to the power of 1/4 over 1. Or you can think of this as multiplying x to the power of, multiplying top and bottom by x to the power of 1/4. Okay. So this cancels, and I'm left with x to the power of 1/4. Okay. So f of x equals x to the power of 1/4, and now it's time for me to write down the domain. The domain. Remember, my inner function is f of x right here, and the domain here is x has to be greater than 0. So although there's no restriction for f of x at the very end, the final product of this, I have to consider the domain of the inner function. So the domain is from 0 to infinity, coming from here. Now let's do g of x. So if I do g of x, and we know that g of x in the beginning, we said that g of x equals x squared minus 4x, and there was no restriction. The domain of any polynomial is all real numbers. So g of x equals, instead of this x, I'll put the g again, which is going to be x squared minus 4x to the second minus 4 times x squared minus 4x. So if I simplify this, I get g of x equals x squared minus 4x times x squared minus 4x. Now minus 4x to the second, and then I have plus 16x. So g of x equals x squared times x squared gives me x to the power of 4 minus 4x cubed minus another 4x cubed plus 16x to the second minus 4x to the second plus 16x. Cleaning this up, so I have g of x equals x to the power of 4. So these two are like terms, so I have minus 8x cubed. And then these two are like terms, I have plus 12 times x to the second, and then I have plus 16x. Okay, so as you can see, this is a polynomial. There's no restriction here. There was no restriction in my original inner function g of x. So the domain of g of x is from negative infinity to positive infinity, or you could say all real numbers. Okay. Let's do one more example. Go to the next page, something that I would have like f and say f of x, g of x, and h of x. So let's see, for this example, let f of x equals, say, x to the fourth plus 1, g of x equals x minus 5, and h of x equals square root of x. So notice that for f of x, there's no restriction. So the domain for f of x is all real numbers, negative infinity to positive infinity. Same thing for g of x. Let me change color. So the domain is all real numbers. But for h of x, so the domain would be all positive real numbers and 0. So it's going to be from 0 to infinity. Okay. So let's do the same thing, find f of g of x. So, but let's do this. Let's do something different. Let's find f of g of h of x. F of g of h of x. So going this direction, my most inner function is h of x. Okay, so first I'm going to find g of h of x. So I'm going to take h and put it inside of g, and that gives me square root of x minus 5. And then now this is g of h of x for f of g of h of x. I'm going to pick this and put it inside of f. So I'm going to have root x minus 5 to the power of 4, and I have a plus 1 in here. And so notice that for the domain of the final product in here, for the domain, I have to consider the domain of h of x and the domain of g of h of x. So for the domain of h of x, remember that the restriction was from 0 to infinity. For the domain of the g of h of x, the restriction again here is from 0 to infinity. So the domain for domain of f of g of h of x also is all positive real numbers plus 0. So from 0 to infinity. Okay, thanks.